In our last episode, we spoke to Ty McDuffie about Grio and Grits, an oral history project he's working on, one that's going to make use of AI to preserve and supplement submitted stories. But it's not a project he could do alone, so he called on his friend Sherrard for some help.
So we go pretty far back, and we've done a lot of things together in the startup world. He always has fantastic ideas. He's an idealist, and a lot of times he comes to me with ideas in order to ground them in terms of what's reality and what we can actually deliver from a technical perspective.
However, with this project, Sherrard was just as caught up in exploring the big ideas, because he knew what AI is capable of and what it would take to build it. Today, we're going to hear more about what it takes to make those AI projects from a previous episode a reality. This is Compiler, an original podcast from Red Hat. I'm Johan Philippine.
I'm Kim Wong.
And I'm Angela Andrews.
On this show, we go beyond the buzzwords and jargon and simplify tech topics.
We're figuring out how people are working artificial intelligence into their lives.
Today, we're talking about the technical side of AI projects. Let's get into it.
All right, let's do a real quick recap from our last episode. We talked about a couple of different AI projects that are in the works. First up, we have Grio and Grits, which Ty McDuffie introduced us into. He's kind of cooking that up with Sherrard, who we're going to hear from more just now. And we also had Chris Kersey, who told us about the Iron Man suit and the Jarvis AI assistant that he's building with it. We're going to revisit both of these in turn. First up is Grio and Grits. So we just heard from Sherrard Griffin just a few moments ago. He's a senior director of software engineering here at Red Hat and a friend of the pod. Sherrard and Ty have worked on many projects over the years, and for Grio and Grits, for reasons we're about to get into, they don't want to grab a complete package like ChatGPT. They want to build something custom. Luckily, that doesn't mean it's particularly out of the ordinary.
From a technical standpoint, this ends up becoming kind of a prototypical AI project. The first thing you have to think about is the data itself. The source of the data, the quality of the data, how you store the data, and how you label and tag that information. So one of the things that the first thing that we're trying to figure out is the source of the data.
It all comes back to data, as it so often does. For Grio and Grits, they are combining many different sources of data. They're collecting raw stories directly from Black communities. They're also supplementing those recordings with historical data from a variety of sources, like museums, and formats including audio, video, pictures, and text. That's an organizational challenge that, for now, they have to curate and organize manually.
That's right. They have to go out and manually collect those stories and then try to basically design a system that can tag if there's like relevant like historical, World War II or like the Great Depression or, different events in history to kind of, tie in the large language model, tie those two things together, right?
Yeah.
We know it's possible, but it does sound like a really daunting task.
Yeah. It seems like it's a lot of work, especially, you do that for let's say just pictures, that would be a lot, but you add in the variety of different media that they're working with, and it just explodes in complexity, right? It becomes like a super time intensive and manual project that it just is very difficult to do.
Yeah, I imagine it's like an information architecture kind of challenge as well, because, how does a machine differentiate between, for example, like we have, different titles for different, historical events. Like how do you, how does a machine know that, the war between the states and the Civil War are the same thing? Like how does it know? Or if a person uses abbreviations for things or, jargon or colloquial things, how does it know to connect those things to other things, that other bits of data that it has collected? So it's interesting.
Yeah. Well, part of the way that they're getting to that is, even though they're looking to have AI start doing some of that heavy lifting, they're going to do a lot of that by hand, because it really sets it up for that future integration of AI.
Mm.
And a lot of this, I told Ty at the early stages, if you can't do it manually, then it doesn't make sense to try to use AI to do it. And that's why we have a group of people who are going through the manual process of this, the manual process of what is it like to catalog and document what these videos will be, what these oral histories will be, and then looking at ways in which we can manually augment the experience just to figure out exactly what will resonate with the users of Grio and Grits.
So in other words, don't just rush in and build an AI to do the thing, right? We've been hammering home this point in the last couple episodes that AI can't really create something completely original. But an AI is very good at replicating a process and applying a logic that's presented to them, right? So if you don't have that end goal modeled for the AI, you can't be sure of what you're going to get. Angela, how does this compare to broader automation projects in general? Does this sound kind of familiar to that kind of project management, or is this completely different?
This is completely different. This is taking the term AI and in all of its taxonomies and trying to make sense of it. This is not automation in the traditional sense. This is more like we're trying to build a model that understands the language and the nuances, and we're trying to train it in such a way because, as Kim just stated, people speak very colloquially and things can mean certain things. This is a different kind of automation and a different kind of training. So being able to do it manually and make it understand sounds like the right thing to do, because you don't want it to go off on a tangent because you don't want people to be misinterpreted and things like that. So I see why they're using such kid gloves with this to make sure that the message does not get lost inside of the technology.
Okay, so we want to do it ourselves first. Then we'll know what's good, what resonates with the audience, make sure that it's accurate. And then you have something that you can show to your model and how to tune it and build it and make sure that it is going to serve your needs properly. Right. So now that we kind of know the process that you have to take before actually building the model, let's get to maybe some of the building blocks that they plan to use for Grio and Grits.
So you have things like VLLM, and you have Ray, and you have Kubernetes. All these technologies are going to be leveraged in order to bring this to life. And then the models themselves, this is going to be fascinating because you have a lot of different models that are out there, both foundational models, actually predictive models, foundation models. But then we're looking at like multimodality. Things where you can describe something in one format, but then the model outputs it in a different format.
Okay, so that was a lot of technologies thrown together in pretty quick succession. Let's go over them real quick. So VLLM, it's a library to help serve large language models to the rest of your stack. Ray is an AI compute engine, which is used to manage computation resources for your AI models.
Okay.
And Kubernetes, I think we generally know what it is at this point.
I think we know what that is.
But just in case you're new to the show, Kubernetes is the orchestration platform that manages everything else and allocates resources to make sure that the whole deployment environment is running well. Okay, so those are some of the main components that you can use in your deployment to get an AI model up and running.
Okay.
Angela, do you have any insights about these tools or this stack or anything along those lines?
Actually, I don't. You lost me at Kubernetes. I mean, that's that I can talk to you about until we're blue in the face. I haven't delved into large language models and things like that yet. That is still on the horizon for me, but there's tons of folks that are really starting to dig in here. It's just not, it isn't on my horizon just yet. I got some other things I'm trying to figure out first.
That's completely understandable. Yeah. What I think is a little interesting is it's kind of mixing some of these really common technologies that we know pretty well along with some of these other new specialized tools that can be built on top of them.
Well, that makes sense. I mean, there's really nothing new under the sun. And we know Kubernetes is really good at what it's doing. It's an orchestration platform. And if you're talking about building large language models, we all know that OpenShift is a perfect platform for running LLMs. So it just kind of makes sense that they're going to use these technologies in conjunction with one another to get this model up and running. It just makes sense.
Okay, so we have a kind of high level look at the kind of tools that you need to build an AI stack. You also need to figure out kind of where you're going to be running these models. Sharrad's going to give us a quick description of how they're tackling that particular problem.
The technical aspect of this project, we're taking this in multiple stages. The first pass of this, it's going to be a few of us with our laptops. I have one with an NPU, Max, trying to play around with these models and figure out what's the right model. You can do things like sparsity and quantization to where the model isn't quite accurate on your local machine, but it'll give you an idea. Some of these models can be very accurate if you use quantization. You can run them locally on your machine. If you have maybe 32 gigabytes of RAM or something like that, you can fit those models into memory on your local machine, ask it some interesting questions, or do some things like speech to text or text to speech, and you can get pretty far.
So you can start small on your own machine and see how far you can take it. Now, that's assuming that your machine has 32 gigabytes of RAM, which not all of them do at this point, but that is kind of within the consumer range of computing hardware at this point. So that's something that you can set up at home. And when you've got that proof of concept working, you can then think about scaling it up to, the monster computers or the cloud deployments stacked with all the GPUs and all that. But if you're really just trying to dip your toes in that AI water, or if you're trying to get that project started and see if it's going to work, you can get an idea of whether or not the AI is going to be producing the kind of work that you want by running it on a smaller machine at first.
Monster computers. I'm just stuck on that word. I'm sorry.
Yeah, and then
Monster
I said dipping your
computers.
toes in the AI water, and I don't know how that's going to come out, but we're gonna ignore that a little.
Very well.
Okay, so you've got your AI tools, you've got your hardware.
Check.
Next comes choosing an actual model, and there are plenty of open source options available.
A plethora.
When you pull these foundational models off of the shelf, whether that's through Hugging Face or some other repository, they only get you but so far. And a lot of times what you want to do is add additional information to it and tune that model so that it's more accurate based on what you're trying to do. Let's say we took a Llama 3 model, for example. Llama 3 covers a lot of different things. You can ask it to tell you a joke. You could ask it to write an essay. You can ask it to, hey, I'm going on a trip to Ireland. Can you give me a 5-day itinerary? That's a very generic model. And as a result, Llama 3 is a very big model. What we want to do is look at ways in which we can introduce smaller, more domain-specific models.
Okay.
Yeah. So, I mean, in the first place, that you can ask one of these huge models such a wide variety of questions and get an intelligible answer is nothing short of amazing to me. That's just wild. But, of course, there's a cost to building and training and tuning and then running these huge models, right? I mean, just because it's got that wide breadth of stuff, it needs a whole lot of data. I mean,
Whole lot of compute power.
A whole lot of compute power to manage all that data and read through it and then generate. And that's just an unfathomable amount of compute power that's needed for all that. And that's, so that it can serve all these features to you, right? But not everyone needs all of those features and capabilities in their own AI projects. Smaller models seem to be a pretty good choice for a lot of people.
I think that's where the world is going to go as a whole. You're going to see more of this inflection of smaller models that are tuned towards domain-specific things. And if you correlate that to what's going on in the industry right now, if you're, let's say, a financial institute, let's say you're an investment banking firm, do you really need a model that tells a joke? Do you really need a model that plans your itinerary for a trip? No, you likely don't. You probably need something that's more geared towards being fine-tuned to answer questions about fraud or anti-money laundering or getting a mortgage and the requirements around a mortgage.
So that's what he means by domain specific.
Mm-hmm.
Yes.
That's right.
Keeping the information very specific to the domain that you're talking about. Mm-hmm. So you don't need it to tell you jokes. You don't need all of that other stuff. Mm-hmm. You just need to stay within the confines of what you're trying to train it for, which in this case is oral histories, correct?
That's right.
Yes.
Yeah, it's going to be specifically, taking those stories that users submit and then bringing in historical documentaries, images, and a whole other of supplemental, again, historical information to kind of enhance that original story, right? But the idea is, you're not planning a trip, you're not even looking for fraud or money laundering. You're just trying to build this historical experience that really enhances the story of your own families.
So starting small seems to be the way.
Mm-hmm. Starting small and then even just keeping it small, right? I mean, you start small with a small model and on a small amount of hardware. Eventually, that data is going to expand a lot and you're going to need to scale up the operations. But in terms of the domain of the model itself, right, you're not going to want to expand the feature set too much. You're just going to expand the amount of data that it's working with.
Gotcha.
All right, let's do one more little quick recap here. Step one, obviously, come up with your project. Pretty simple, pretty straightforward. Step two, do it yourself a little bit, right? First, to see if the output is interesting, to see if AI is even an appropriate tool to be doing this for you, and then to determine what can be automated with AI and what can't, and if it's going to be accurate enough for your needs. And then you build your initial platform and choose your appropriate model, and then kind of build that small scale project that you can then scale up into the stratosphere later on. Congratulations. Now you have the parts that you need to build your model. There are, however, a few more steps in there, like training the model in some cases, and then tuning it, which is probably something that you're going to be doing in most cases.
Mm-hmm.
And when that's done, your work isn't over yet. There's one more crucial component that you just cannot do without.
Humans are at the point in the AI journey where we still cannot be removed from the process. And Grio and Grits will be no exception to that. We fully will be utilizing human in the loop type of feedback, where even if we use generative AI to do very interesting things, there will still be a person for every single piece of content that we use Gen AI for, to validate and ensure that what we're delivering and what we're putting out there is of the highest standard. So that's very key, because history is a very touchy subject. We have to make sure it's objective. We have to make sure that it's accurate.
History is touchy enough of a subject when it's still just human focused and human centered, because the different points of view that you have, the way you present the information, right, that there's all sorts of biases that can come out, and you want to make sure that if you're going to introduce AI, that those discussions don't get lost and that you are still producing the best possible quality content that you can, right? AI can help you be more productive and more efficient, but if you care about accuracy and about quality, you cannot trust the model to do everything independently. Speaking of doing things yourself, we're going to check in with Chris Kersey and his Iron Man suit when we get back. Kim, could you do me a favor and remind us a little bit about Chris's project?
Absolutely. So Chris Kersey is an Atlanta-based technologist, and he is really active in cosplay. And one thing that he noticed while doing cosplay was that a lot of the Iron Man cosplays were just not practical, and they also didn't do the things that now in the realm of modern technology are very similar to what has been portrayed in comics and also in the films. So he decided to take on the Herculean task of building a real-life Iron Man suit. Is that good?
That was perfect. Thank you.
That was great.
Thank you, Kim, for that.
Yep.
Wonderful summary.
Cool.
I'm just remembering from the last episode that the kinds of things that he wants to do with the suit are all very cool. But to me anyways, and again, I'm pretty much just a layman at this point, the logistics of it all seem pretty daunting. When we first saw the Iron Man suit in the movie, it didn't seem like it was remotely possible, right? But now,
Yes.
now it's a different story. And when Chris recently thought about what it would take to make it all real, it seemed very much within reach.
There was no idea about what hardware you'd need or how would you even accomplish what we were seeing with like Jarvis from the Iron Man movies. And once OpenAI became available, once you had a ChatGPT, which is they've got an API that you can access, that's where it became finally feasible that maybe I could include that. But I knew that, we had all the components at that point. We already have speech to text, we had text to speech, and so then you just put the AI in between it and you have a full AI assistant. And once I realized that I think all of these components were finally available, it was definitely in my head that I would have to incorporate it for that. Like I said, recreating the experience of Iron Man, recreating that Jarvis assistant that can help you out and is there to answer questions about what you're trying to accomplish.
So in other words, we have the tools, we have the technology. It's just a matter of putting it together now, right?
Yep.
Yeah, that's always the easy part.
Is it though?
Well, it's not exactly like Tony Stark in a cave with a box of scraps, but there are different components. Chris just mentions, like the open AI, like the API that you can access, like that open up a world of possibility for building like an AI assistant to be kind of embedded into a local device. Like that's kind of the foundation of the work that he's trying to do here. And like we've talked about with Sherrard earlier, like it's just a matter of really figuring out the different components that can be used, and then figuring out what essentially the stack that you have to like put kind of like a tech stack together. It's the same thing that we've talked about before on the show. It's just a matter of figuring out how it all kind of fits together with this newer technology that's coming out.
Yeah.
Very intriguing.
Yes.
And having the plan, knowing the parts, having the parts available, that's all a huge step. But as with a lot of creative work, it's going to take a little time to make it, into what you imagined it to be. Chris's first attempts at this Iron Man suit and the Jarvis assistant, they worked. They were a little clunky. There was a significant delay between him giving a command and then the suit reacting and doing the action. But it did work. And the technology has gotten better very fast. He's been working on this for maybe like a year and a half, I believe. Since the AI came out. And he's been able to do a significant amount of progress on this project. And he's also built a kind of a workaround to speed things up and provide more consistency that was lacking from his initial attempt.
Sitting in front of the AI assistant right now is a command and control interface that kind of intercepts stuff before it goes to the AI. And right now, that's what's handling suit control. So I wrote a command and control engine that basically understands when I'm asking it a question, that this is something that it needs to go look for an answer for. Not AI-based answers, but like, what's the temperature in the suit, or what time is it? These are very rudimentary questions that it can get from the system and not have to go to AI, because AI typically doesn't have these sorts of answers.
That's interesting.
It is.
So it's the AI that you're asking questions of, and then it's the system itself doing its own self-checks, asking of itself. Like, the temperature of the suit wouldn't be in the AI,
No.
or anything anything within reach right now would not be in the AI. So that's interesting. How is he differentiating between the two?
Yeah, I'm not sure how they how the AI
Yeah.
itself differentiates between questions that can be answered by local feedback or locally found information, I guess, and something that needs to go into a cloud. Not sure about that, but I do know that what Chris has done essentially is kind of like reverse prompt engineering, making like a bunch of preset questions that he knows that people that, if he's demoing the suit, for example, at an event, that he knows people are going to ask, or that he can ask people to ask the helmet or ask the suit. So he's, essentially it's all manual. He's feeding questions or preset questions, just to kind of show the proof of concept and show exactly how the system can differentiate between something that's more what the temperature of the room is, or what time it is, maybe GPS location, where are we now, we're in Atlanta, Georgia, that's an LLM is not even needed for that.
Absolutely.
So those are kind of preset questions that maybe he has now as a proof of concept.
So what that looks like is it means that this command and control interface that is doing exactly the things that Kim just described, he's had to come up with and then hard code a set of commands for his helmet to pick up on, because he had to also set it up in such a way where it's listening constantly and listening for a wake word, just like Alexa or Siri or any other AI assistant. And then that interface then interacts with the AI assistant to produce the output that he wants. That sounds like a really extensive, time-intensive process to me, right? Hard coding all those questions, getting all the different variations of questions in there, or making sure that you're picking up the questions at the right time. And I'm hoping it sounds a little bit familiar, because he did the same thing that Sherrard just advised to us, right? You do the thing manually first. But of course, that's not the end goal.
The dream, the next thing I actually probably am working on from the AI perspective is not having to have that command interface in between anymore. It's allowing the AI to understanding what I'm asking and then giving it access to functionality that it can call when I'm asking it to do things. And it's actually a lot more powerful. Then you don't have to code in every single thing you may ask it. You just have to tell the AI what it has access to, and then it can query it or activate it when it thinks that that's what you're asking for.
Okay.
So more agentic AI is what he's talking about.
Yeah. So eventually he's not going to need that command and control interface where he's putting in every question and the answers that he's looking for and all that. He's just going to be able to talk to the AI, and it's going to figure out what he wants and hopefully interpret it correctly and then perform the action that he wants. And that's probably not that far off at this point, especially with some of the ready-made models that are available on the internet. Here's the thing, though. In order to get this done, you have to keep the project's context in mind. It's an Iron Man suit. It's going to be used at convention centers. And you can have your suit call on an internet service like ChatGPT to power the AI portion of it. But if you're in a convention center, when it's crowded during a Comic-Con or something similar where you've got a lot of people running around, things aren't going to be able to provide that reliable, consistent internet connection that you need to power your suit's AI functionality.
And so anything you're trying to access will either cut in and out on you, or it will just be unreliable. You don't know what your bandwidth will be, which really does present a problem with anything you want to be interactive. And so once these LLMs, these large language models, once they started to become available, you started to see companies also come out with smaller versions of these large language models that can be run locally on smaller devices with less memory.
We could put together some Bigo cards at this point about small AI models, right? Sherrard and Ty are planning to run their initial versions of the project on a laptop with many fewer parameters and features than what's available with huge LLMs, and they'll probably stay on a more focused model. And again, that's exactly the kind of thing that Chris is trying to do as well with his Iron Man suit and the Jarvis AI assistant.
I love that. Very, very technologist solutioning there. Like, what's the solution? Bring it local. Bring it closer to you.
Yeah. And Chris is thinking even smaller than Sherrard and Ty. It's a huge challenge, right? Because again, you all you've got is this suit. So you're running everything on the suit.
Locally. Yeah.
Locally. Yep. So your hardware limitations are going to be a huge consideration to get those AI models shrunk down small enough to run on something that you can wear on your body underneath those pieces of armor that you've got. Now, that's nothing that's completely new to hardware or software development, right? Hardware limitations were a huge consideration in development for a very long time. But then computing resources kind of outpaced the software requirements by a big margin. And it's maybe not as big a consideration for a lot of people these days. However, with edge computing, it's becoming relevant again. And with how power-hungry AI models can be, it's a real balancing act between the resources you have available and the functionality that you want to provide.
There were really two things I had to do, which was number one, you have to shrink your memory footprint as much as possible on all of the processes that are running on the device. You have to get that as tight as possible. Because again, the large language models take up a pretty good chunk of RAM. And so I'm really running the device I have absolutely up to its memory limit. I'm using every byte and then going into swap space a little bit occasionally when you're a little too close to the edge. So that's the first big thing you've got to overcome is how do I fit so much functionality onto one device?
That's literally a whole other level that you have to keep track of when developing your project, right? It's not just how do I make it work? It's how do I make it work? And then what are the constraints that I have to work on with? And how do these two things intersect, right? This is a huge, huge undertaking for him. But wait, there's even more to keep in mind.
You can tweak how you use power consumption. How do I want, do I give more power to the CPUs and so I have more CPU power? Or do I give more powers to my GPU, which is actually doing the AI processing? And so there was some of that tweaking that had to be done because the responsiveness of your AI has a lot to do with how fast your GPU is running and how fast it can process that information and give it back to you. And so there was definitely a balancing act that I had to do, not only with the memory, but with the processing.
That's a lot, right? That's great. It reminds me of the kinds of things I would read about in books like Soul of the New Machine, or about how game developers for early consoles, especially like the Super Nintendo or the Sega Genesis or the Atari, they had to come up with super creative ways to make their games fit on an incredibly limited amount of memory space.
Tank controls and JPEGs, skyboxes, baby.
But this just means that they have to go back to the beginning and become more creative in how they're utilizing the resources that they have. They just have to be more creative.
Yeah, absolutely. It's been a bit of a lost art, which hasn't left completely, obviously. I mean, Chris works on a lot of these smaller machines, and he's kind of bringing that stuff back for entertainment reasons. One question that kind of came to mind is it worth bringing back? I mean, we have this issue of internet connectivity, right? But are Wi-Fi and cellular network improvements going to make this resource juggling obsolete again? Are we going to need to keep running things locally, or are we going to get to the point where it's not just compute resources that are getting really good, but also networking resources that are available?
Good question.
To us? We'll see. Time will tell. In the meantime, Chris is still building his project on very small machines and doing some really amazing work. There are, however, some other considerations at play.
The other direction I was going to take it is cost, because if you're using a commercial AI solution, every part of that conversation is costing you pennies. And so, you end up in this case, kind of like early cell phone usage, where every time you wanted to make a phone call, it was going to cost you a minute or two. And so you thought about how you wanted to use your minutes. Am I going to call my buddy, or am I going to call my mom because I only got 300 minutes this month, or whatever the case may be? And so same thing with AI, right? Is if I'm using a personal assistant, whether it be in the suit or whether it be in your home, and how are these going to cost me? Whereas if you bring that home, if you run it locally on your own hardware, it's not costing you anything but the electricity to run the device.
That's something I don't miss about old phone plans, is trying to figure out
either
who you're going to call and how long you can call them for, and
and rushing
distance.
Everyone's calling you after 9 p.m. because that's when the minutes were free.
Yep.
Oof. They will never know the struggle. They will never know the struggle.
Truly.
So that's a big advantage of being able to run things locally, right? Is that you could, even if the Wi-Fi technology or cellular technology got good enough that when you're in a congested space, you could use it without any delays, you're still thinking about, oh, okay, this is a commercial solution. How much do I want to be paying for my AI assistant to be doing these things for me? Or if I run it on my own machine, I get it working and I don't need to have those considerations in mind. All right. That was a lot for the suit, but
that was.
It's I find it to be a fascinating project because it's, number one, just this really cool recreation of what we saw in movies, however many years ago, that at first seemed impossible and now is very much within reach, and also getting kind of this closer look into the considerations of how to get it done has been really eye-opening, because even though, again, we have the technology, it still takes a lot of work to get it working properly.
I think we're right. I think we're lucky. Right now, we're at the precipice of all of this technology kind of converging together and making what we thought wasn't even remotely possible just a few short years ago. Think about when Iron Man came out.
2000
don't tell me. I don't want to know.
Early aughts.
Early aughts. It's like 2003, 2004.
Something like that. Yeah.
And now we're like, no problem. We have a AI assistant for that. It's so
2008.
The possibilities are there, and I love the fact that we can see those technologies. They're right in front of us. So we just have to hold on just a little while longer before we have our own Iron Man suits.
Oh man, that would be
I
fun.
would love my own Iron Man suit.
And the original Iron Man movie came out in 2008.
2008. Okay.
2008.
So
Yeah.
17 years ago ish. It would take a couple months.
Yep.
Oof.
Yeah.
All right, let's bring it home. What do we need to keep track of when planning an AI project? What was the number one thing we each learned from this episode?
We need to keep track of, you don't always have to start big. You can start small. Smaller, more localized models might be the way.
And doing things manually, like you can't underestimate the human in the loop, so to speak.
Yeah.
It still needs a lot of manual work to set these things up and to figure out all these components and how they fit together to get the solution that you want.
And for me, it's just what's possible within the limitations, right? Like the idea that you can run something as powerful as an AI assistant on a small little edge device that you can wear under a suit is amazing. Now it's, comes with its drawbacks, right? You're not going to have that full Llama 3 model that Sherrod was talking about that's telling you jokes and planning an itinerary for you and all these other things, right? That's not going to fit on whatever resources you're going to fit on your body. But you can still get something that's incredibly useful and incredibly entertaining on a very small form factor. And that to me is nothing short of amazing.
Absolutely. We want to know what you thought about this episode. I mean, the Iron Man suit right in our hands. I mean, who would have thunk it, right? You have to hit us up on our socials at Red Hat using the hashtag #CompilerPodcast. Do you see any other applications for AI tools in your projects? We'd love to hear about it. And that does it for this episode of Compiler.
This episode was written by Johan Philippine.
Victoria Lawton could build a fellow AI in her sleep.
Thank you to our guests, Sherrard Griffin and Chris Kersey.
Compiler is produced by the team at Red Hat with technical support from Dialect.
Our theme song was composed by Marianne Chutta.
If you liked today's episode, please follow the show, rate the show, leave a review, and share it with someone you know. It really helps us out.
Thank you so much for listening. Until next time.